APCAM, this is a video on molarity, which is a concentration unit. Okay, it's the concentration that we use about all the time in chemistry. There are other concentration units like parts per million. You might hear if they're measuring the amount of lead, like in our drinking water. Something called molarity. There's something called just percent of solute in a solution. So what we typically use is molarity. And molarity is this. It's how many moles of solute there are. It's like if we're doing like a salt solution, how many moles of NaCl there are per 1 liter of solution. Not per liter of water, per liter of total solution. So for example, here is a 0.1 molar solution of copper chloride, 0.1 molar copper chloride. What that means is this is a 1 liter container. That means that in this liter of solution, there is 0.1 mole of copper chloride. Now, I obviously don't have a scale or balance that measures in moles, but I know how many grams 0.1 moles of copper chloride are. If I want to make this into a 1 molar solution, I would have to add more copper chloride powder, dissolve more in there to get to a full mole of copper chloride in this liter solution. If I wanted to make this less concentrated, it's hard to remove the solute, but I could add more water and dilute it, which would decrease the number of moles per liter in there. So this solution is pretty easy to tell. If I had two of them, it'd be easy to tell which one's more concentrated because of their color. Okay, or like Kool-Aid, you could taste them and see which one's more concentrated. Generally, most solutions are clear. You can't tell which one's more concentrated. So if I was doing a reaction in aqueous solution, which a lot of reactions we do are in aqueous solution, if I needed to use like 0.05 moles, I could figure out how much of this I would need to use to get 0.05 moles of copper chloride. Okay, I need to figure out how many milliliters of solution I would need to get that many moles. So this is going to be number 14 on your molarity notes. So letter A there wants to know, what is the molarity of a solution if you have 16.3 grams of ammonium sulfate? So we're trying to find molarity. So we need to know moles of ammonium sulfate and divided by how many liters we have a solution. Now, by the way, when you're making these solutions, we use something called a volumetric flask. AP test tends to ask about this often, but this flask, the volumetric flask, this is a 250 milliliter volumetric flask. It's only got one mark on it right here. So I maybe would put a little bit of water in, put in however many grams of solute I need to put in, whether it's copper chloride or ammonium sulfate, whatever it is, and then I can fill to the 250 milliliter mark exactly right there. So that gives me 250 milliliters of solution, not of individual water, but of total solution, since this is of total solution, which includes the solute dissolved in there, which takes up a little bit of space also. Most times I would use a 1 liter one of these that only has a mark at 1 liter. So I get exactly 1 liter of solution as I'm mixing these up. So again, that's called a volumetric flask, has one mark on it. All right, there's number 14A. You got 16.3 grams of ammonium sulfate. We want to know the molarity of it. So we need to turn this into moles. So we're going to go grams to moles, and the grams down on the periodic table would be 132 grams. So if I divide those, that gives me moles. I'm going to keep going. And I want to know the molarity. So molarity is always moles per liter. So I need to divide by the number of liters. Now there's going to be nothing on top of this conversion. So it's per 500 milliliters, which would be a half a liter. So divide these two to get moles, divide by 0.5, and I get 0.25. Usually we just put a big M. They're usually italicized. Obviously can't do that in here, but that means 0.25 moles per liter. In other words, it means there are 0.25 moles of ammonium sulfate per liter of solution. If I put this many grams in that much liquid, it becomes that concentration, that many moles per liter. You can just put a big M, or you can put moles per liter. Letter B there. How would you make 2 liters of a 0.1 molar sodium carbonate solution? And it gives you the molar mass of sodium carbonate. So one thing I never do is I never start with my molarity. My molarity gets me from moles to liters or liters to moles. So if it gives me a molarity, I can use that to convert from moles to liters or liters to moles. So it's saying you want a 2 liter solution. And I really want to know how many grams do we need to use of sodium carbonate to make this solution? How many grams of it? So if I want to get from liters to moles, I use the molarity. If I was going moles to liters, I can use the molarity. And the molarity is 0.1 molar. That means there's 0.1 moles of sodium carbonate per 1 liter of solution. We're trying to make a 2-liter solution. So those labels cancel. Multiply 2 times 0.1. I need 0.2 moles of sodium carbonate. To get into grams, I'd say a mole of sodium carbonate is however many grams. It tells you on there is 106. So moles cancel, we're left with grams. So I would need 21.2 grams of sodium carbonate. So if I want to make 2 liters of a 0.1 molar concentrated solution, that's not very concentrated, I would need to take 21.2 grams of this and add water until we have 2 liters of solution. That says solution, sorry. So I take that many grams, add water until I'm at 2 liters of solution in a volumetric flask, and I'd have a 0.1 molar solution. There'd be 2 liters of it. Erase this. Letters C and D. C, how many milliliters? We need to finish with milliliters. How many milliliters of a 0.45 molar solution would be needed to make 0.25 moles of K2CO3? Again, I never start with my molarity. So we have 0.25 moles of K2CO3. And wants to know how many milliliters of the 0.45 molar solution would be needed to get that. So I know moles needs to go on the bottom. I'm not going moles to grams. I'm going to use my molarity here. Our molarity is 0.45 molar, meaning there's 0.45 moles per liter of solution. Put that in here. 0.45 moles of K2CO3 per 1 liter of solution. Or instead of putting 1 liter solution, that would be the same thing as 1,000 milliliters, since asking for milliliters. There's that many moles per 1,000 milliliters of solution. So this is my molarity. It's written upside down because I'm trying to get from moles to liters. This is 0.45, by the way. It's hard to make it big. So I'm just taking that, divided by that, times 1,000. I would need 555 milliliters. So I would need 555 milliliters of this 0.25 mole, of this 0.45 molar solution. So a little bit over half of it, or a little over half a liter of this solution to get that many moles of K2CO3. Last question is a dilution problem. Okay, last one's a dilution problem. So we're diluting a solution. I might let you guys kind of do this one. I might make a different one up here and let you do this one. So here's my example. I have HCl in the back. Okay, concentrated HCl comes as concentrated hydrochloric acid comes as 12.2 molar. That's as concentrated as it can be. Can't make it any more concentrated. It's saturated at that point in time. Full solute. Let's say that I have a big container of it. Okay, I actually have almost, we'll say right there, let's say I have 3,000 milliliters, or I have 3 liters of that container. So I have a whole bunch of it. Let's say I want to make 200 milliliters of 3 molar HCl. So I've got this really concentrated HCl that I have a lot of. I want to take some of it and get it diluted to 3 molar. So obviously we need to put some water with our HCl. Remember, you always add acid to water, not water to acid, always alphabetical order. But as we're doing this, okay, we're going to do something called MV equals MV, where that's molarity times volume. Let's think about that for a minute. Molarity is moles per liter times liters. Well, those cancel. We're going to end up with moles. So really we're saying moles equals moles. Moles equals moles. All right. So really what I want to know in this question is this. I know I don't need all 3 liters of this. I want to know how many liters, or probably how many milliliters, do I need to use of this to make 3 molar HCl that is 200 milliliters. So how many milliliters of that? And then how much water do I need to mix with it? Well, the number of moles is not going to change. The number of moles is not going to change. It's going to be the same number of moles here as there. So MV is moles equals moles. So we can simplify proportion here. We can say we have some 12.2 molar solution. I want to know what volume I need to use to make a 3 molar solution that is 200 milliliters. And it doesn't matter if we're in milliliters or liters as long as we know it's the same on both sides. Okay, so I want to know how many milliliters of this solution that's really concentrated to make 200 milliliters of this solution. So multiply that and divide by 12.2. Multiply those, divide by 12.2. I'm going to do that real quick. Since I just made this question up. So we've got 600 divided by 12.2. 600 divided by 49.2. So we need 49.2 milliliters of 12.2 molar HCl. So that's really concentrated HCl. So we need 49.2 milliliters of this to make 3 molar HCl that is 200 milliliters in volume. Now, obviously you need some water in there. So you would take this and you would mix with, remember, acid into water, mix with whatever 200 minus 49 is. So 150.8 milliliters of water. So I would get 49.2 milliliters of 12.2 molar HCl and mix it with 150.8 milliliters of water. That would give me 200 milliliters of solution now, and it would now be 3 molar concentration. Again, that's called a dilution problem. That's it.